Hello 108 students, welcome back to section 6.4, and we're going to tackle page 2 and continue on our general systems approach to factoring. Here we're going to work on a step 3 or objective 3, which we're now going to talk about factoring three terms or a trinomial. And the shortcut we're looking for is, again, this is all review, but a perfect square trinomial. Do you have one? And so my method to help you see this is look at the third term and ask yourself, is it a perfect square root? And I'll go down here and try to use that with example 3a. Look at the third term. Start here. Can you take the square root of 25? If you cannot, then forget the rest of these. It can't be a perfect square trinomial. You could try reverse FOIL or FLOY. Okay, but then step number 2 says look at the first one. Can you take the square root of p squared? The answer is yes, and I like using the parentheses. So I've got the first term is a perfect square, the second term is a perfect square, and I've got them written like that. Now the catch is this, step 3, you got to pass the acid test. Is the middle term equal to the two square roots multiplied and doubled? Okay, and there's a couple ways you could say that, but multiply the two square roots and double them. Does it equal the middle term? So let's look at this example here for 3a. You've got p times 5 is 5p and double it. So p times 5 times 2 would be 10p. Do you have that in the middle term? And when the answer is yes, then you've just proven you do have a perfect square trinomial. So what you can do, drop down the first square root, drop the sign, drop the third square root, give yourself a set of parentheses, and then double it. Make sure you put the 2 there. Now what I'd happen to do over here was I was using regular reverse FOIL or FLOY and coming up with p minus 5 times, that's a mistake right there. Sorry, that should be a plus right here. Excuse me. That should be a p plus 5 times the quantity p plus 5. So a lot of you will look at this and say, hey, I'm just going to use reverse FOIL, but if you see it, it makes life a little easier. Okay, so I'm going to scoot down here and let's take a look at example 3f. I picked a couple here, and here we go. You're going through your general approach. You're taking your reads. What's rule number 1? Always look for what class? Okay, hopefully you said GCF. Do you have one? 28, 6, and a 10. They're all even, so you can at least pull out a 2. When you pull that out, what are you left with? 2 times 14z squared. 2 times 3z is 6z. 2 times minus 5 is 10. Minus 10, so you're on your way. Okay, so that 2 is always a factor. Now inside the parentheses, you ask yourself, oh, is this, look at the third term, is that a perfect square? No. AKA, can you take the perfect square root of 5? And the answer is no. So you don't have to do any more of the perfect square trinomials. Just start using FLOY or reverse FOIL. And 14 I factored down into 7z and 1z. And I plugged in, for negative 5, I put a plus 5 and a negative 1. Remember, the order could matter, but when you go here and unlock the safe, you get 5z and you get minus 7z. Add them up and you get the second term. Okay, so again, this is all review. Objective 4 or step 4, I should call them really steps here. What do you do if you happen to see 4 terms? Now when you see 4 terms and they say factoring, you have to think of parentheses. You want to factor by grouping. Okay, and that's what I tried to show you. And what you're hoping here, and you see a problem like this, is that when you group the first 2 terms and the second 2 terms, you are going to luck out, pull out the GCFs. So I look at this guy and I see y squared and y to the third, so I know I can pull out a y squared, leaving me x minus y being multiplied to produce that first term. Then I come over and look at the second term and I see x to the third minus x to the squared, so I can pull out x to the second. Remember, it's the smallest exponent, and you're left with x minus y. And then I get a little sigh of relief because I look inside the parentheses and they are exactly the same. So now when you do factoring by grouping, you do a double round of GCFs, but instead of the GCF being like y squared or 3 or 3x, you're pulling out the parenthesis, x minus y gets pulled out. That's the GCF. and what's left are the terms in front of it. You bring them down and you got it. Okay. Okay, I guess that's about all I have to say here for this section. It's a good general review. You get some more problems here. Think of yourself, like I said, like Kellen Moore, and you're looking at the polynomial and how quickly can you read it, how quickly can you decipher, can you go through and figure out what you're dealing with so you can accurately factor it. Okay, so with that, I'm going to sign off here now and say we've signed off, check off on page 2. We have completed 6.4, and when I come back, I see we will start 6.5, and we will be doing solving quadratic equations by factoring. Okay, that's all for now. I'll see you later. Bye.